Now we shall simplify our conventional notion. So suppose there is a element f in Sn. So if therefore f is a function from in to in onto in. In is a set containing n elements, 1 2 3 up to n elements. So under f, 1 is say mapped to f1, 2 is mapped to f2, 3 is mapped to f3, and n is mapped to fn. Then our notion was we will write f as 1 2 3 n f2 f3 fn. Now we will do some more simplification. That is, we will drop the columns. Suppose there is a column I fi. We will drop this column I fi if fi is equal to I. So let us take an example. Suppose we are in I6 and let us take a function f from I6 to I6, or element f in S6 is like that. So we are seeing that there are two elements where the mapping is identical. So we'll write this in a simplified manner like this: 1 2 3 5, like this. And we will also have to mention that f is a member of S6. So basically what we are doing, that we will drop the column for which fi equals to I, and we will have to also mention that the function is a member of which group, because from this we cannot tell whether if this element is in S5 or S6, or even it may happen that this element may belong to S7. So correctly identifying that element, we have to mention that the element is belonging to S1, S2, S3 or S6, whatever. So now we will give a definition of cycle. A permutation if on in or if belongs to Sn is called a K cycle if there exist K elements in in the elements say I1, I2, Ik, such that f of I1 is I2, f of I2 is I3, f of I3 is I4, f of I suffix k minus 1 is ik, and f of ik is I1. So this is called a K cycle. Basically, if we'll draw a circle, suppose this position is I1, this position is I2, this position is I3, this position is I4, and let's say this position is I k minus 1, and this position is say ik. So what is happening, I1 is getting mapped to I2 under F, I2 is getting mapped to I3, I3 is getting mapped to I4, so on, and ik minus 1 is getting back to ik, and ik is again getting mapped to I1. So this is the idea of cycle, and the length of the cycle is k, therefore it is called K cycle. So let us take an example to understand this concept. So I6 is 1 2 3 4 5 6, and let's say under, suppose sigma belongs to S6. So sigma is a mapping from I6 to I6. So sigma is a bijective mapping from I6 to I6. And let's say under sigma, 1 is mapped to 2, 2 is mapped to 5, 5 is mapped to 4, 4 is again getting mapped to 1. And the rest elements are mapped to identically. So suppose this is 1, 1 is getting mapped to 5, 5 is getting mapped to 1 is getting mapped to 2, 2 is getting mapped to 5, 5 is getting mapped to 4, 4 is getting mapped to again 1. So this is basically 4 cycle. So the element sigma in S6 is 1 2 3 4 5 6. 1 is mapped to 2, 2 is mapped to 5, 5 is mapped to 4, and 4 is mapped to 1, and the remaining elements 3 and 6 are mapped to elements. So this is basically 1 2 4 5, 2 is mapped to 5, 5 is mapped to 4, and 4 is mapped to 1. So this is in S6. So the general notion of writing a cycle is like this. This is 1 2 5 4. That is 1 is mapped to 2, 2 is mapped to 5, 5 is mapped to 4, and 4 is again mapped to 1. So this is the notion of writing cycle. So in this fashion, the 6 elements of S3, we wrote the elements as F1, F2, F3, F4, F5, F6, like this. So in cycle notion, we can explicitly write the elements of S3. So S3 will be, there is element identity E, there will be a 2 cycle 1 2, there will be a cycle 1 3, 2 cycle, there will be a cycle 2 3, there will be a 3 cycle 1 2 3, and there will be a cycle 1 3 2. Now this cycle 1 2 means in S3 is the element 1 2 3, 1 goes to 2, 2 goes to 1, and 3 is 3. So writing 1 2 or 2 1 is same, and the cycle 1 2 3 in S3 is this, that is 1 is mapped to 2, 2 is mapped to 3, and 3 is again mapped to 1. So this element is 1 2 3. So explicitly the elements of S3 in cycle notion is this. So there are 2 3 cycles, and there are 3 2 cycles, and one identity element, total 6 element. Now important note is that a 2 cycle is called transposition.